Today we're starting lesson 8.4. The name of the lesson is minors and cofactors, but what we're actually learning how to do today is find the determinant of a matrix and what a determinant is. And then in the next lesson, lesson 8.5, we're going to look at some actual uses of determinants. So we start this lesson by solving the system that you see right here. A sub 1x plus b sub 1y is equal to c sub 1, and a sub 2x plus b sub 2y is equal to c sub 2. And so we're going to go over to the other side of the board because we have more room over there. And we're going to solve this equation by using elimination. So we're going to have, what we're going to do is we're going to take the first row and we're going to multiply it by a sub 2. Times a sub 2. We're going to take the second row and we're going to multiply everything by a sub 1. Better yet, negative a sub 1. So regular elimination, something that you're used to since you were in algebra 1. Let's see what we've got. We have a sub 1, a sub 2x plus a sub 2, b sub 1, y is equal to a sub 2, c sub 1. And we're going to change the marker. Then we get negative a sub 1, a sub 2x minus a sub 1, b sub 2y is equal to negative a sub 1, c sub 2. We're going to add those two together. And so you can see that the x's are gone. We get 0x plus a sub 2, b sub 1, y minus a sub 1, b sub 2, y is equal to a sub 2, c sub 1 minus a sub 1, c sub 2. So it's not pretty. What we're going to do next, we're going to factor the y. Y is equal to, we're going to factor the y. This is a sub 2, b sub 1 minus a sub 1, b sub 2 is equal to a sub 2, c sub 1 minus a sub 1, c sub 2. And then we're going to divide on both sides by a sub 2, b sub 1. So divide by a sub 2, b sub 1 minus a sub 1, b sub 2, which is, on both sides, like I said, divided by a sub 2, b sub 1 minus a sub 1, b sub 2. So let's go to one side. Y does not look pretty. Y is equal to a sub 2, c sub 1 minus a sub 1, c sub 2 over a sub 2, b sub 1 minus a sub 1, b sub 2. I'm sorry about this. You'll see just a little bit later why I'm doing this. I will multiply the top and bottom now by negative 1. So 1 more step. Multiply top and bottom by negative 1. And we get that y is equal to a sub 1, c sub 2 minus a sub 2, c sub 1 over a sub 1, b sub 2 minus a sub 2, b sub 1. Like I said, be patient, you'll see why we did this. Now, rather than take this expression and replace y by it, it looks really horrendous. It could be done. Rather than do that, what we're going to actually do is we're going to eliminate the y's now. So let's eliminate the y's, and we're going to solve for x. We're going to eliminate the y's, and we're going to solve for x. To eliminate the y's, I'm going to take the first equation, the top equation, and I'm going to multiply going to take the bottom equation and I'm going to multiply by negative b sub 1. So let's do that. The top equation, and on both sides, of course. Let's multiply on both sides. The top equation becomes a sub 1 b sub 2x plus b sub 1 b sub 2y is equal to b sub 2 c sub 1. The bottom equation becomes negative a sub 2 b sub 1 x. Sorry, left. Let's see. That's good. Minus b sub 1 b sub 2 y is equal to negative b sub 1 c sub 2. Let us continue. And what do you notice? No more y's is what you notice. We have a sub 1 b sub 2x minus a sub 2 b sub 1 x is equal to b sub 2 c sub 1 minus b sub 1 c sub 2. Just as before, we're going to factor the x. X times a sub 1 b sub 2 minus a sub 2 b sub 1 is equal to b sub 2 c sub 1 minus b sub 1 c sub 2. And what do we get? We divide now by a sub 1 b sub 2 on both sides, a sub 1 b sub 2 minus a sub 2 b sub 1 on both sides. There we go. A sub 1 b sub 2 minus a sub 2 b sub 1 on both sides. And finally, we end up with, let's write it down here, x is equal to b sub 2 c sub 1 minus b sub 1 c sub 2 divided by a sub 1 b sub 2 minus a sub 2 b sub 1. Now, the reason I multiply top and bottom of this equation by negative 1 is so that if you look at the two denominators, they are exactly the same. The only way my system has an equation is if a sub 1 b sub 2 minus a sub 2 b sub 1 does not equal 0. So the quantity a sub 1 b sub 2 minus a sub 2 b sub 1 determines whether the system has a unique solution. Okay? So that's the reason why the number a sub 1 b sub 2 minus a sub 2 b sub 1 is called the determinant. Now, let's take a look one more time at our equation. I'm not going to look at all of it. I'm just going to look at the coefficients. So let's figure out the coefficient matrix. What is the coefficient matrix? So the coefficient matrix, and I'm going to erase everything else, it is unnecessary. So the coefficient matrix is a sub 1, b sub 1, a sub 2, b sub 2. And we notice that the product of those two elements, so the product of the elements across, located in the main diagonal, so a sub 1 times b sub 2, minus the product of the other two entries, so minus b sub 1 times a sub 2, is the determinant. And so we stop right here we have learned what a determinant is. A determinant is a number. It's a number associated with a square matrix, and it determines two things. One, whether there's a unique solution, and two, it really determines whether our matrix has an inverse or not.